Hello everyone, so this is my student-led activity. I'm going to be doing a simple machines activity and relating that simple machine to energy and how they create work and how they make work easier. So, my handout is more or less like a brochure. You'd have to fold it for it to kind of make sense, but it's geared towards kindergarten grade level. The standard is plan and conduct an investigation to compare the effects and different strengths or different directions of pushes and pulls on the motion of an object. The supplies you need are 2 people, but I decided to use chairs, but we can manipulate that into the activity. A milk or water jug, like so. A utility rope, which is right here, and a broomstick. Safety precautions, no hair in your face, no open-toed shoes. My knees are actually behind me. In the regular scenario, they'd be standing, so that's why that's a precaution, but my feet are going to be behind me, and I can't wear shoes in the house, so no loose-fitted clothing that could accidentally be pulled by materials, so no strings or anything like that, and workspaces must be neat and free of clutter. I only really have these materials here. So basically what we're going to be doing is we're going to be lifting an object 3 different ways. 1 with just our bodies, and then 2 with simple machines. So the first would be, in this scenario, you would have students just lift up a jug. So let me bring the screen up here. There we go. I'm a little bigger now. They would lift the water jug up here. For us, it's very easy. For them, it could be very difficult, especially when they're teeny tiny little kindergartners. So that's the first way. Then I'm going to go back to the directions. You're going to have 2 students hold the broomstick on their shoulder. Then what you're going to do is you're going to tie an end of this rope to the jug. So I'm going to do it this way. So tie it in. And you can really use any type of rope just as long as it's durable. So just a simple knot, just like this. And what we're going to do is we are going to take our rope and toss it over the top there. And then what we're going to do is we are going to pull on the other side this jug and see what happens. So ideally these would be 2 students, but again we don't have that. So I would essentially be taking my 2 hands and pulling on the jug. So pulling, it doesn't come off, and we are lifting the jug that way. So that's going to be the one way, or the second way. Then, going back to our directions, we are then going to have the same 2 students, but then we're going to tie the jug, or actually not tie the jug, tie the rope differently. We're going to tie it to the broomstick, not the jug. So it's going to look a little something like this. Let me whiten it. Okay. So we're going to do this. And instead of tying it to the jug, we're going to tie it to the broomstick. Then we're going to loop the rope through the jug. This, and then toss it over. And then we're going to essentially do the same thing. So after all of this is done, you'll talk to your students about exactly what happened and if they noticed a difference in the amount of force that they had to put onto the jug in order to get it to perform work. So going back to our handout here, there are a couple of resources that I found that would be beneficial to teaching this and just giving a better idea to students exactly what a pulley does, what work is, what force is, all those concepts that we might find to be difficult to teach. So a couple of online resources that I saw is What is a Pulley? Lesson for Kids. So this is actually just a YouTube video. And it's very simple. It's geared towards preschoolers and kindergartners. And it's a quick little 2-minute video. And it's very cute and fun. And I think a lot of kindergartners will really be receptive to it. Then there is another online resource, and I like videos, so I feel like I'm much more receptive to videos. So where did it go? All my other homework's popping up. There we go. There it is, hiding. So then there is a fixed pulley definition lesson for kids. We can actually just copy and paste this right on in here. Right here. And this is actually, it has a lesson transcript for another lesson you could do. It's very, very similar, but I think that the video is relevant to what we're doing. So that's why I liked that. So I just wrote some different examples of the integration of this activity. So a couple of different ways that you can talk about different topics with this activity would be maybe something like weight, where we need to talk about how if an object weighs more, then the more force you have to apply to it. So like the heavier you lift something off the ground, or the heavier something is, the harder we have to try to lift it off the ground, would be a concept for kindergartners. In a shared writing practice, we can talk about what we experienced in our experiment that we conducted, and that way we can practice early literacy skills as well. It is important that teachers emphasize that the purpose of simple machines is to make work easier by incorporating less force than we normally would be required to manipulate and act upon an object. So, and then of course, it's describing what type of work is the scientific definition. So is homework work? No, because we're not really providing force to move an object a certain distance. Is pushing a book across a desk work? Yes. Students can connect to the real-world situations through elevators and exercise equipment. Those are really simple yet common ways that pulleys are used, and students can conceptualize this and be able to make those connections. A teaching technique that aids in the incorporation of digital literacy is providing instruction through the new literacy, such as providing the videos, such as exactly what I talked about. And another teaching strategy would be to picture prompts. So like the picture I incorporate at the bottom, just provide that, provide no explanation, just ask students what's going on. And I think it might be a little cropped out, which I'll have to fix, but it's essentially a kid pulling on a pulley and a newspaper or a box is coming up in the air. So that's basically what that was talking about. I'll fix that for my actual submission, and so that should be taken care of. Now, the ways in which, I'm just going to grab my notes, the ways in which the 5 E's are incorporated, the engagement would be just prompting their prior knowledge. What do you think the term work means? And a lot of students will say, oh, my mom and dad go to work, oh, I do homework, and then we can talk about what work means in a scientific definition. So, and that's when we start to introduce the lesson. So I put that we're going to make a machine that will allow us to use less energy to create work. And then explore. So just manipulation of the ways in which they're lifting the water jug through their hands, through one way to tie the rope, which I would essentially do that. I would just make it a concept that they understand what's being tied, because I don't think many kindergartners can tie ropes. And then just talk about the different ways that we manipulate our simple machine in order to accomplish the same task. elaborate. So we would be reiterating that simple machines are used to make work easier. So again, going into those concepts like, why did we create this simple machine? How does it make the work easier? And then evaluate, which would be like my assessment. I wouldn't really do any formal type of assessment with this. It would be more or less like a collaborative discussion, the shared writing process that could be an extension onto what we've already learned. So just practicing our literacy skills maybe. They can't write yet, so they would be essentially just talking, and I write as they talk, and then the classroom discussion at the end. So that is my student-led activity, and thank you for watching.